Well, hello there, science students. Mr. Zana here with your new Ed Puzzle. This Ed Puzzle is going to be a review for your Unit 4 exam coming up on either December 10th or December 11th, depending on if you're an A or a B schedule student. Unit 4 is investigating characteristics of the universe, and we're going to be discussing everything from stars and nebula and galaxies to electromagnetic forces. We're also going to be discussing the Hertzsprung Russell or HR diagram and how it relates to a star's size, luminosity, and temperature. So let's get started. First thing we should look at here is your unit organizer. Your unit organizer, again, should be used as a study guide. It has all of the different teaks or the different things that we've learned during this unit. It also has right here is your words to know, your vocabulary words. Then it has 3 questions here that you should be able to answer by the end of this unit. Okay? And as you see right here, December 4th, 7th, those are the 2 days we're doing this Ed Puzzle as your review. So we're on track. So what I've provided on here is a filled out version of your unit organizer so that if it is not completed as of yet, virtual students, you'll be able to pause this video, you'll be able to take a look at that and determine what you need to fill in for your unit organizer, okay? So we've got the stars, nebula, and galaxy, and it has all the pertinent information for it so that you can fill it out, all right? So let's get into it. A star is born. So the birth of a star takes place in a nebula, okay? Stars are made of burning hydrogen and helium, and that's what's giving off that light that we see in the night sky, all right? So a star is born continued. A newly formed star is called a protostar. So just like a prototype car is the first car or a new car, protostar is a new star. Their very basic structure has just developed. A star spends the majority of its life as a main sequence star. You're going to see them on the HR diagram. They're stretched all the way across the spectrum. And you're going to see there are far more of those type of stars than any other type of stars on the HR diagram. Our sun is a main sequence star. Okay, so the sun that we use to grow our food and to keep us warm and to keep our planet alive is a main sequence star, which means it's in the longest portion of its life right now. All right, the nebula is a cloud of dust and gas where stars are born. That is basically the birthplace of stars. You could also call it a nursery for stars. And you need to remember that. Remember that the nebula is a cloud of dust and gas where stars are born. Now, our galaxy is a system of billions of stars, dust, and gas held together by gravity. All right? System of billions of stars, dust, and gas held together by gravity. Continuing with the galaxy, we know there are 3 main types of galaxies. We have the spiral. It looks like a pinwheel. It's this one here on the left. Elliptical is egg or oval shaped. That's the one right here in the middle. And then you have your irregular, which is not really a defined shape. And you see it here. It's kind of just a mass. It's not really a defined shape. It's not going to be, a circle or a square. Or, it's going to be just kind of a clump or a mass. All right. Now, here is your Hertzsprung-Russell diagram. Now, what you need to remember about the Hertzsprung-Russell diagram is that you're starting on the right side here at the bottom with the coolest of temperatured stars, working all the way to the left to your hottest. Now here's your luminosity, and here is the brightness of a star, and it starts down here with the least and works its way up to the most bright. All right? So right here, again, temperature gets hotter as you go from right to left. Luminosity gets brighter going bottom to the top. If you don't remember those, it's going to be very difficult for you to do well on the exam, all right? So here is yet another way to look at it. It's just a different type of illustration. So you're looking here, least temperature, all the way up here, the increasing temperature, and again, increasing brightness. So it's just showing you here, our sun's here, main sequence, here are supergiants, here are the giants, and here are your white dwarfs. It's just a different illustration of the one that we looked at here, okay? So I put it in there because I want you to have whatever visual aids you need to be able to study by and remember this information, okay? So if you need more than one, guess what? Here's a third. So this one, again, hot to cold, dim to bright. Says it right there for you, and it shows you supergiants, giants, main sequence sprinkled right up through the middle, and then your white dwarfs, all right? So there you have 3 different illustrations of the HR diagram so that you can remember that they go cold to hot, right to left, or in this case, this one says hot to cold, left to right, and then dim to bright from the bottom to the top. So, which star is hotter, a white dwarf or a red giant? White dwarf or a red giant? How about which star is brighter, a red giant or just a giant? Which type of star is the brightest and hottest on the HR diagram? Brightest and hottest. All right, we're going to look at the electromagnetic spectrum. The electromagnetic waves are sorted by their wavelengths. And we have a chart here for you to follow. So you'll see the wavelengths are very long here, and then they shorten up as we go all the way down through PET scans and from radio waves, all the way down to PET scans. So we have a description here, radio waves. Your radio captures radio waves emitted by radio stations, bringing to your favorite tunes. Radio waves are also emitted by stars and gases in space. So each one of the different types of waves are expressed or given a definition so that you will know the difference between them. And you're going to need to know the definition between them because we're going to have some questions about them, okay? So what type of ray would you use to check for a broken bone? What type of ray would you use to check for a broken bone? How about what type of ray would you use to make some popcorn? And lastly, what type of ray gives you a sunburn? All right, well, that is your ed puzzle. We're going to have a couple other things to do during the review today. I'm sure Ms. Kanopik is going to work with you on either a Kahoot or doing some in-class examples or possibly both. So thank you for your attention. Please make sure that you review this again if you're having trouble with some of the concepts. This will be available to you to go over multiple times before you have your exam on the 10th or 11th. So please use it as a tool to help you study, and good luck.